Hi everybody and welcome. Today we're going to be talking about solving systems of equations, except this time with quadratic functions. So your goal after watching this video will be able to find where two quadratic lines, or a line and a quadratic function, intersect. So what does this look like? Where would we use it in the real world? Why are we doing this? So if you remember that example we had of, and you'll have to forgive my beautiful artwork here, Steph Curry shooting a basketball. We'll put him on the coordinate plane here. So here's the ball, goes up, goes up, goes up, goes down, and he shoots it. And part of the thing that's out of the shot, there's a whole reason why you can even see this, is, maybe in the corner, there is a camera, and again, beautiful camera there, that is basically recording this from above. That way you can see the shot going in. So the camera needs to be focused on the rim so it can see it, but it also wants to make sure that, it can see the hoop, see the top of the shot, but you don't want the ball going out of your picture, for example. So if we're looking at a camera angle, we could think about that as a line, and I'll trace that in green here. So this is one line on the coordinate plane, and then Steph's shot we'll put in yellow, and that's what it would look like. And a question like this we might want to solve. All right, so where is the camera going to intersect with the ball? Or when will the ball be directly in the middle of the shot of the camera? So that is an application of seeing, where something intersects with a quadratic function. So solving it today, we can see these on graphs, the points where they intersect. These would be the solutions. And we can also solve this algebraically. So we can go ahead, do the work, set these equations equal to each other, and solve. So let's do an example. So something like this might be Steph's shot. And then something like this might be our linear camera angle. And how do we solve? Well, just like we do a system substitution, we have two y's. Y is the same thing as y, which means that these have to be balanced. So we can take this and set it equal to this. So we take y on one side, and we set it equal to the value of the other y. And after this, it's just going through and solving. Now this is a quadratic. And the only way that we can solve these is by setting them equal to 0. So that's your goal for today, is we need to get it set equal to 0. So anything that is on the right side, we need to move it over. So x squared minus 7x plus 6 equals minus 4. And again, we want this whole side to be 0, so let's move everything over. And be careful, make sure you are only combining like terms when you are doing this. And now that it's set equal to 0, this is a function that we know how to solve. So you can use the quadratic formula, or you can put this into a box to solve for those x values. So x squared, 10. It's a plus 10 here, so we got 5 and 2. Looks like we can add those to get 7, which is what we want. And again, minus 5 and minus 2 make minus 7. Minus 5 times minus 2 gets us positive 10. So this is exactly what we want here. Set that equal to 0. Keep working through. Set this equal to 0. Set this equal to 0. Add 5 to both sides. That's our first point. Add 2 to both sides. That's our second point. Okay, so we have x equals 5 and x equals 2. Now previously, we were just looking for something on the axis, but now these are points in space. So we need both an x comma y value for each of the points that we intersect at. So we have to take these and go back to either of our original functions, and I'll highlight these in blue, so we can use either this or this and plug back in. So that is the important step here, because once you solve for x, we need to plug back in. So we can take that function x minus 4, and we can use that. You could use the other one. It's going to get you exactly the same answer, I promise. If you don't believe me, you can do it right now. So we'll get one point is x equals 5, y equals 1, and then our second point (2 minus 4) is negative 2. So we would get y equals 2, comma, negative 2. So the 2 points of intersection are at 5, comma 1 and 2, comma negative 2. So that's the idea for solving these. Again, we set them equal to each other. We set it equal to 0. We factor. we solve, and we plug back in. So quite a few steps here, but as long as we keep careful track of what we're doing, we'll be in good shape. A second question, because I know that these are a bit tricky the first time you go through, is another system. What if we have two quadratics that this time intersect? And we're solving this system. The steps do not change. We still take this and set it equal to this, because again, y equals y, so we're allowed to do that. 2x squared, 15x plus 7 equals x squared, 10x and 1. And then again, set it equal to 0, so move everything over. So move your x squared over, move your 10x over, move your 1 over. And if we do that, we can see we'll get x squared, 5x, and 6. And there's nothing left on the right side, so it's 0. We're ready to put this into a box and factor. 2 and 3 get us positive 6. Set that equal to 0. And then each individual piece we can now solve for. And then our last piece of this function is to take these and now plug back in. We can choose either of the functions. And again, I'll highlight where we're going from. Either of these we can plug back in for. So maybe x squared plus 10x plus 1 equals y. So we can do negative 2 squared plus 10 times negative 2 plus 1. 4 minus 20 plus 1 minus 16 plus 1, or y equals minus 15. So negative 2 comma negative 15 is 1 point. And again, we can do that same thing now for our minus 3. Everywhere that we see an x, we're putting in our minus 3. And then we just use PEMDAS, follow our order of operations to solve. So our two solutions are negative 2 comma negative 15 and negative 3 comma negative 20. All right, so a bit of practice today, only one video because our only skill today is setting these things equal to each other, factoring, solving, plugging back in, and getting our x comma y ordered pair answers. As always, any questions, feel free to reach out. Thanks for watching.